First, want to ask if you can all hear me clearly, right? Okay. I'm super excited to be here, and of course, I want to welcome you to a new semester, and you also welcome to my class. Okay, so I'm basically going to do what I call a brief introduction about, telling you something about myself, the class expectation before we go into the course. Okay, so my name is Kazim Adepoju, originally from Nigeria. Has anybody heard about a country called Nigeria in Africa? Okay, thank you so much. So I had my Bachelor of Science in Statistics, Masters of Science in Statistics, and PhD in Mathematical Statistics, all from University of Ibadan, Nigeria. I got my PhD in Mathematical Statistics in 2016. And of course, along the line, I actually got a scholarship to present my PhD work at the University of Oxford in the United Kingdom, which I did in 2015. Of course, let me just say, unofficially, I started my teaching career at college level in 2005, and officially in 2010, I started from Africa. I taught in Africa for so many years before relocating to the United States. And of course, this is going to be my fifth year at the School of Statistics, University of Minnesota. I'm also an assistant director of undergraduate study, and I've published more than 40 papers. Okay, you can actually access my research or papers online. Okay, so let me tell you this. As far as I'm concerned, there's no area of statistics that I cannot teach. There's no area of statistics that I cannot relate to real life. Okay, even though this particular course is a theory of statistics, okay, but you know what? I want you to follow the course with an analytical mind. There is no notation, there is no symbols that cannot be related. Okay, so the way I learn my statistics, the way I understand my math is being able to relate that to real life practical situation. Okay, of course, I need, take me as a friend in case you need clarification, in case you get stuck. Of course, you can actually, contact me. And if I'm very fast in my talking, or if I'm very slow in my talking, of course, you need to be able to tell me because I actually want to be statistical in my talking. Okay, so I award extra credit, in case you actually, if I ask a question in class and if you answer my question correctly, you basically earn an extra credit. That's going to be extra credit of 1 point, and you can be accumulating that. Okay, at the end of the semester, when the final exam is in, I need you to send me a message, just tell me how you want to spend your extra credit. You could spend your extra credit on assignment, on midterm, and on finance. So I need you to, you're going to advise me. Okay, so let me tell you this. Even though this course is going to be challenging, but I can actually, the way I'm going to handle it is going to be, you're going to find it more rewarding. All what I just need from you is to ask questions. The greatest sin in the whole world is not murder. Murder is not fine, right? But I don't see that as the greatest sin. So the greatest sin is when I deceive myself. I can deceive other people. It's not good to deceive, right? They're going to report me to police or report me to constituted authority. But what if I deceive myself? Who am I going to report? Myself. So, and that is the reason why you understand yourself, you know yourself. The moment you get stuck, please reach out. You pay for the service, you deserve to be served better. There is no area in statistics, there is no area in mathematics that cannot be applied. You know, the moment you understand the essence of what you're doing, like the reason why you are doing what you are doing, the moment you understand what happened behind the scene, you're actually going to appreciate what you're doing. Now, this is theory of statistics 2. I actually want to believe you have a prerequisite to discuss. Of course, some of you done theory of statistics 1. Okay, this is going to be like a continuation of theory of statistics 1. And let me tell you this, what are we going to do here? What are we going to learn here? Okay, you know, the theory of statistics is more or less going to be mathematical statistics, you know, where we need the knowledge of math to be able to, you know, put our model in place. Let me tell you this. Before I go into this course, I think I need to tell you the reason why we find ourselves in doing what we're doing now. We don't just do what we do now. Why do we find ourselves here? Why do we find ourselves learning the theory of statistics? Because the theory of statistics has to do with you having what I'm going to call a deep understanding of theoretical development of formulas, method, modules like that we use. Why is it that you need to study that? Why can't we just be satisfied with the one we have? We can never get satisfied because situations in reality is changing, and there's going to, you know, the reason why we need to keep on studying, like modifying the existing formula, is to look for a way, you know, our model is going to commiserate with reality. Reality keep on changing. We don't need to be static. We need to be flexible. And that is the reason for you to be able to modify, for you to be able to create new model, then you need to first demonstrate an understanding of the conventional model. So the moment you understand how they develop a model theoretically, then you will be able to, you know, capitalize on the weakness of the model and modify to suit the current reality. Okay, this is it. We find ourselves, the lecture has started, we find ourselves in a world that is stochastic in nature. The world is complex. Different things happen in different days. This world is, we have a multi-state of nature. At times we're going to be happy, at times we're going to be mad. At times when I get home, my wife is going to be dancing, is going to be smiling. And at times when I get home, oh my God, she's going to look so sad. Why do I need to get worried if I want to go home? If there's no variation, I don't need to worry about anything. We worry because of the fact that different things happen in different days. That's why we get worried. Okay? Now, as human beings, we want to secure our environment. We want to understand our environment. You know this will happen? The existence of reality is independent of human knowledge. I'm going to say that again. The existence of reality, the existence of the physical world is independent of human knowledge. Now, if I want to understand my environment, if I want to understand my political environment, my medical environment, my psychological environment, you know, whatever environment, then I need to have a statistical knowledge. Why do I need to have a statistical knowledge? Because the reality is statistical in nature. The reality is stochastic in nature. The reality is probabilistic. So if I really want to understand the environment, then that is what I need to do. Oh, I want to understand my environment, right? I want to secure my environment, right? What do I need to do? Then I need to go into population because I need knowledge. We need knowledge to understand our environment. Where will the knowledge come from? The knowledge will come from information that we got. Oh, information will translate into knowledge, right? Where does the information come from? Oh, information comes from data. But you know what? When you collect data from the field of inquiry, When you collect data, the information that you need is not readily available. Oh my God, I wanted to bring something like a Coke, a canned Coke. Let me just assume, I'm just assuming, let's say this is a Coke. Everybody know Coke, like soda? Okay. This is a Coke. This is my data. But you know what I need? I need the liquid content, right? The liquid content is the information. Where after drinking that, what am I going to do? The other one is going to go into a trash. Okay? What is going to go into a trash? That is the error. That's a loss of information, right? And what we want to do here, we actually need to minimize what goes into a trash. Therefore, I need Moodle to get the information from the data. Then I got to make sure I use the best model, okay? So that's because if I use inferior model, a poor model, there's going to be a very huge loss of information, okay? So yeah, and that is the reason why we're going to be focusing on equations. Equation is like a model, okay? We need to understand our model because model is what will actually give us information that we need in the data. Okay, when you collect your data, your information is not available. Then it need to be analyzed using appropriate statistical model. And that is why we're doing what we're doing now. Okay, well, for you to be able to understand 4.1 or 2, we need to first review 4.101. That is the theory of statistics 1. This is the theory of statistics 2. I remember in the summer semester, I taught theory of statistics 1 this last summer. I have my lecture video on YouTube. If you put my name, basically in case you want to, because you need to review 4.101. It's still the same textbook. And I'm going to tell you where we're going to start from. But this is the situation. Okay. Now, starting now, I just told you we need information to be able to understand our environment, whether medical, political, and so on like that. And of course, the knowledge of statistics and probability is actually needed. In theory of statistics, we need the probability and statistics. But you know what? Students actually confuse probability with statistics. Some students we have, are they the same? Or can they be used interchangeably? And my answer is no. They can't be used interchangeably. So what I want to start doing, where am I starting from here? Because the knowledge of probability and statistics is what we basically, we want to let the theory about that. That's why I call it theory of statistics. And you can't separate statistics from probability. You cannot separate probability from statistics. You know what I want to do right now? I basically want to tell you how they operate. Now, the whole thing is going to start. Whatever we do, if I want to understand my environment, I told you the other time, we live in a world where we don't have knowledge. We seek for knowledge, right? I want to get that. What are we going to do? We're actually going to go into population. If I want to conduct a study, okay, I'm going to go into population. Okay, now, if you take a look at this population now, I just want to demonstrate. Okay, in this population, I get 100 balls. Okay, distinguished by colors. 60% of them are black and 40% are red. I'm basically going to call this guy a bag, a population that has the totality of the characteristics of interest. Am I talking so fast or so slow? Are you getting me? If you are not getting the information, you pay for the service. You need to challenge me. If you are not getting what I'm saying, please make sure you tell me. Okay? I want highest level of sincerity. Okay, now this is the population, right? You know what statistician is going to do? Statistician like me. Because we can't study the entire population. We don't have resources for that. We're basically going to I'll take a sample, right? The sample is the data. You see data? Okay. Now, maybe out of so many balls here, okay, I choose randomly. I choose 5 balls. Okay, I choose 5 balls randomly. Okay, and I realized that I observe in my selection, we got 2 black balls and 3 red balls. Okay, now if I want to use probability theory, okay, if I the difference between probability and statistics, let me first tell you, when we're talking about statistics, we're talking about analysis of the frequency of past events. I'm going to say that again. Statistics has to do with the analysis, okay, of the frequency of the past events. But when we take a look at probability, the probability is forward looking. Statistics is backward. You are going backward, you're going retrospective. You want to understand the world, you go retrospective, you go historical, you analyze the past. But the probability is not going to say, okay, I think I know something about the past. Can I talk about a little bit about what is going to happen next? And that is the reason why we say probability has to do with predicting future events. Okay, future event. Now, when you take a look at this now, if I know what I have in the bag, okay, I know what I have, what I have in the population, but I basically want to make a prediction about what is going to be in my hand. What I'm going to have in my hand is a sample. Take a look at this. This is a sample, right? And that was why I said probability is going to say, okay, given that we got 60% of black ball in the bag, okay, what is the probability, okay, that 2 out of 5 balls that I choose randomly will be black? That's probability. So the probability is going to look like, okay, when you look at what you have in the population, in the bag, can I predict what if a certain characteristics of interest in my hand? But when you talk about statistics, you're going to say, okay, based on what I have in my hand, okay, based on what I have in my hand, can I make a conclusion or inference about what we have in the bag? Take a look at that. So statistics, just like maybe my wife is cooking and I say, okay, baby, can I have a taste of that? Okay, because I'm not going to eat everything before I know how it tastes, right? I'm just going to taste a part, right? Okay, but I'm gonna tell my wife, okay, try to steal that homogeneous, right? Okay, and she's gonna give me a part. When I taste it, do you know what I'm gonna have in my mind? If it tastes good, I will generalize, okay, based on my observation of a sample of the field. Can I make an inference, a judgment about the population? Now, you see the difference between probability and statistics now. Okay, but let me tell you this. When we are trying to make, based on the observation of the sample of the field, if we want to make a judgment about the population, in statistics, we still use probability knowledge. Why is it that different statisticians get different results? When they work on the same thing, they get different results because they are different school of thought in probability. We're still going to talk about all of that. We got a frequencies approach, we get a Bayesian approach. Okay, so we're still coming to that. So far so good. Any question? Is there anyone? I used to ask this question. Well, I remember my first day in this university in 2018, where when I talk, I was not talking like this, and some students were not really getting, my accent, and I keep on asking every day when I teach in this part of the world. I ask whether is there anyone who is struggling with my accent. Oh, okay, I'm super excited. Okay, but you know what? Do not hide your feelings, okay? Let me know. Now, we want to focus more on statistics, even though we cannot separate probability from statistics, okay? But you know what? Because we basically using the knowledge of few, the knowledge of the sample to make a conclusion about the population, okay? Because of that, you know, largely what we're going to be doing in statistics will be about estimation, okay, of an unknown parameter. What do I mean by parameter? What do I mean by estimation? Parameter is a population characteristic value that we seek to know, that we seek to determine. I'm going to say that again. Parameter is a population characteristic value that we seek to determine. Let me give you an example. How popular is the president of the United States? That's a parameter. That's unknown. Okay? Okay. And that parameter is going to be proportion. Okay? I want to know the popularity of the president. Or maybe I say, okay, what is the average household income in the United States? Or what is the average household income in a particular country? That's a parameter. Okay? I'm basically going to be referring to mean in that regard because it's unknown. Okay? Now, if it is unknown, okay, what do we need to do? Okay, there's a way we can get parameter directly. If I want to get exact value of parameter, I will need to, use everybody in the population. But that's not possible because we don't expect a doctor, do I need to, if I want to know what is wrong with this patient, do I need to extract all the blood in the system? That the patient will die. We don't necessarily need to study the entire element in the population. So when you don't study entire element in the population, you are not getting parameter value exactly. But what are you going to do? We're actually going to take a sample from the population. When you take a sample from population, it means you are no longer getting an exact value of the parameter. What are you getting? You are estimating. That's what we call estimation. Okay? You are estimating. And then when you are estimating, you are not getting an actual value. Okay? When you are not getting an actual value, then we're going to do a lot of validation. Basically, we want to see the value that we arrive at is it going to be the best guess? Is it going to do the job? Okay, so we're gonna do all of that. Okay, now I want to focus on proportion as a parameter. I said something the other time. How popular is the president? If I want to know that, right, I need to go into the population. Okay, then I'm going to start asking. And the response that I'm actually going to get is going to be dichotomous. It's either you say, okay, this is the question I'm going to ask. Do you approve the work the president is doing? It's going to say yes or no, yes or no, yes or no. Okay. Then I'm actually interested in counting the numbers of yes. Okay. Now take a look at this. In the above, we start with notation now. Please pay attention to notation. Okay. It's going to be easy. Okay. Now, I'm going to let Y, okay, be 1 if now I'm focusing on ball now, okay? Now, the same way that I'm focusing on ball, okay, if I want to go politics, I'm basically going to say, okay, maybe I'm interested in a particular ball, okay? So if I'm interested, maybe it could be a red ball, it could be like here now, I'm interested in black ball, okay? I'm actually naming that one. Okay, we're going to, the other one I'm not interested in, I'm going to call that 0. Okay, and of course in 4101, you know that if I have a random variable that can take out 2 possible, nature, it's basically going to be Bernoulli distribution. Okay, so don't forget the other time. If you take a look at the other time, how many balls do we actually choose randomly? 5, right? Okay, so if it is 5, the first ball, let's say I close my eyes and I'm okay, let me see the first ball. The first ball could be either black or red and so on like that. Okay, so that is what I actually mean here. Okay, where I said y is going to be summation of yi, okay, which is going to be the numbers of black balls. I'm interested in black balls. You may be interested in something else. And that's why you need to define your characteristics of interest, what you are interested in. Okay, and I'm actually going to, when I'm taking a sample, okay, I'm actually going to apply principle of randomization. Okay, in such a way any ball can be chosen, okay, from the population, and it has to be independent. Okay, so each of that y1, y2, up to y5 will follow Bernoulli distribution because the probability distribution, okay, of a random variable that can take two possible nature is Bernoulli. Of course, we've done that in 4101. Okay, so that is why you have that, and that follows Bernoulli with parameter P. Okay, now we're coming into that now. What are we interested in? Oh, the essence of going into the bag is basically to figure out the probability of getting black ball. So the probability of getting black ball become proportion. And that is why the unknown parameter in Bernoulli distribution is going to be P. That's what we want to figure out. Okay? We want to figure that out using our knowledge of, observing just sample. How many balls? Just 5 balls. Okay? It means we're basically going to be estimating that. Okay, now, and we know the possibility. We know the possible values P can take because it's a proportion. Okay, it's going to be 0, 1. Take a look at that. Okay, now, I already know that why follow Bernoulli. Of course, let me tell you the difference between binomial and Bernoulli. Okay, when you actually have a random variable that can take two possible nature in terms of outcome, if you add one trier, that's Bernoulli. But if you have more than one trier, that becomes binomial. So binomial distribution is a generalization of Bernoulli. Okay. Now, and don't forget, the sum of Bernoulli is going to be binomial. And that is why you see y here is actually the sum of each Bernoulli. Okay. So y now is now going to follow binomial. Okay. The parameters is now 5 and P, but this is no longer a parameter because we know the number of sample that we're going to choose. Okay, now take a look at that. Now the goal is to estimate the unknown parameter P. We're not getting that exactly. We're only going to estimate that. Why do we want to estimate that? Because we're working with sample. Whenever you're working with sample, you are estimating. You are not going to get exact value. Okay. Now, so we want to estimate that using what? Using the y1 up to y5. Don't forget you choose 5 balls. Now, if you want to do that, there's going to be a lot of guess. Okay, about what that value is going to be. Okay. Now, if you actually choose just one ball, and if that very ball happens to be black, that's going to be 1, right? Okay, if you stop at just one trial, okay, that's not going to be fine. Okay, because that is giving you that equal to 1. You know what that is giving you? As if when you go there all the time, you're always going to get black. It is not going to happen. Okay, that is why this is not going to be a good estimate. Okay, but a reasonable estimate or a better estimate in statistics is when we put into consideration the power of average. In statistical analysis, we use average a lot because it is mathematically proved has statistically observed that average, okay, provided, some other condition hold, average can actually be used as a best guess of the unknown parameter value. Okay, so take a look at this. I'm performing experiment now. Don't forget, in my experiment, when I choose 5 balls, 2 of them are black, right? And 3 are red. And of course, I'm going to label out the black going to be 1 and red to be 0. So what I'm trying to say, the first ball I choose is black. Okay, the next one is red, red, black, red. Okay, and based on the fact that I want to consider what we call a best guess in statistics, I can compute the average. Okay, now I'm going to add them up, and I'm going to divide by 5. That will give me 0.4. Now, the 0.4 that I'm actually having now correspond to the fact that, it's talking about 40%. Okay, but in the real population, the percentage of black is 60. But what I'm getting now, okay, is 40%. But let me tell you this guy here is an estimate of the parameter. It's not the real value of parameter. I told you the other time, when you take a sample, whatever analysis you do on sample, it's not going to give you the exact value. Okay. And that's why at times whenever there's an issue in the house, I'm going to tell my wife, if my wife actually want more expectation from me, I'm going to say, you know what? We live in an approximate world. The world is not exact, so I'm not likely to be exact. I'm going to say, oh, okay, I just realized you are not perfect. That's what you're telling me, right? Okay. And there will be peace in the house. So I apply my statistical knowledge in my house. Oh, too. Okay. We actually got an estimate, right? That's an estimate. Oh, let me tell you this. What is the difference between this guy? There's a difference between this guy and this guy. I'm going to tell you. This is an estimator, okay? Like a formula, okay? The formula that I'm actually using here, okay, is an estimator, but this guy is an estimate, okay? The process of getting this guy is an estimation, okay? I just wanted to take note of that. Okay, now the question now is, what does good estimate mean? How do I know what I got is a very good estimate? We got a 0.4 the other time based on that experiment. So how am I so sure that 0.4, okay, is, represent, denote reality? Okay, we got a way to investigate that in statistics, and we're going to do that a lot in this class. When I have an estimate, how can I prove to the world it's a very good estimate? Okay, the beauty of statistics is that we got a way to validate our approach, which I'm going to walk you through in this class. Okay, so how do we utilize our data to conduct effective estimation? At times, the data we collect may not be in good statistical standing. How do we actually restructure our data set for us to be able to get a very good estimate from it? Okay, we're also going to line that in this course. Okay, now the knowledge of probability theory will actually be used to to address the problem. Okay, so I told you the other time, there's no way we can separate probability from statistics. Okay, in this course, the theory of statistics that I taught in the fall ended in chapter 6. Okay, and this course actually starting from chapter 7. Of course, I have uploaded the electronic version of the textbook on Canvas. You can access that. So we're going to cover all this area, and there's another chapter 16, Bayesian. If you check the syllabus, you're actually going to see the topics we're going to cover. Okay, we want to review 4101, and we advise that you review 4101, particularly chapter 2, 3, 4, and 5, 2, 3, 4, and 5 in 4101. Okay, I'm going to do some demonstration now. When I'm done, okay, now, and revise your knowledge of random variable, what we just did right now, okay, it's a random variable. We are assuming, when I talk about random variable, okay, I'm actually, we got random variable from a random experiment. When we perform experiments repeatedly, you get different results, when you go into the box, you pick a ball randomly, okay, when you pick the first one, okay, it's either it is black or red, okay, which means, it's going to take a value 0 or 1, okay, so take a look at all of that, okay, that becomes a random experiment. Of course, we got a pickup to be y divided by 5, which is the summation of y divided by 5. At times, okay, if our random variable may not be 0, 1, it could be something else. We are dealing with proportion, it's basically going to be 0, 1. But if you're dealing with something else, okay, the random variable is going to have what I call a state space, possible state of nature. Okay, for instance, take a look at, a random variable can be discrete or continuous. You actually, if you go back to chapter 3 and chapter 4 of the textbook, or you revise your knowledge on discrete and continuous random variable, discrete random variable is going to have a discrete probability distribution. The continuous random variable is going to have a continuous. So if you take a look at this, this is an example of a discrete, okay? And if the state space here is from 0 to 2, and this is like the frequency, which is actually telling us, okay, what is the numbers of time 0 occur? I told you the other time, statistics is the analysis of frequency, okay, of past events. Okay, how many times does a particular value of a variable occur? They say this occur 1/3 times, 1/2 times, 1/6 times. And when I add all the probability value together, that's going to give me 1. And this is more or less talking about the plot, if you want to generate what I call histogram, okay, if you want to know the distribution, okay, graphically of a random variable, you can actually plot that, okay, and of course, you can make an inference. Okay, if I have this scenario, what is the probability of S is going to be less or equal to 1? Less or equal to 1, so 0, 1. Okay, then I can also find the expectation, okay, the expected value of X, okay, where we're going to use that. So I need you to revise your knowledge of that. Then, for continuous, where you have f of S equal to that, and the state of nature is between 0 and 1, okay, and, if you want to get a CDF, you're actually going to perform what I call antiderivative. Let me tell you, in this course, you need to revise your knowledge of calculus. Okay, so of course you're going to get that here when you integrate that. Okay, that's going to be S squared. Okay, then you can actually find the probability of S lie between A and B. Okay, the lower f of S is going to be PDF, that we call the probability density function, and and the upper f of S is going to be called the CDF. Okay, so then you need to know, how do we find the expectation of X, and how do we find the expectation of S squared, and how do we find the variance. But because of my time, I quickly, because we're going to be using distributions in this course, okay, and what I'm going to do, I'm actually going to, talk more about and review the distribution. Give me 1 second. So I'm going to review the distribution. Okay, so I need you to pay attention. Okay. It's very, very important. Let me see. Is it this one? Oh, not this one. Let me see board. Okay, that is the light. Let me see. Why is it not? This is screen up and down. Oh, okay. Okay. Oh, okay. So when I go down. Okay, now what I want to do now, I want to review some probability distribution that we're going to use in this course. And what I need you to do is to pay attention. Okay. In this course. Let's start with Bernoulli. Okay, we next follow Bernoulli with parameter P, the probability of X. Can you all see that, right? Okay. Okay, so it's gonna be P raised to power X, 1 minus P raised to power this, and X start from 0, 1. Okay, this is Bernoulli. Okay, review that. Okay, understand what does it mean? Okay, what is the variance? Okay, now if I'm talking about binomial, binom NP, okay, the probability of X will be N combination X, P raised to power X, 1 minus P raised to power that, X start from 0, 1, 2, until you get to N. Okay, you also need to review that. Okay, you need to review that. So another one that you actually are going to review is geometric. This is Bernoulli. Okay, this is Bernoulli, and this is binomial. Okay, then geometric. Okay, X follows geo with parameter P. Okay, the probability of X is P 1 minus that raised to power X. X start from 0 yeah, 0, 1, 2, that goes to infinity. We have two forms of geometric. Okay, there's another one. Okay, that's basically going to be this, and that is going to start from 1. Okay, we got two forms of geometric. Okay, so let me see. Because I'm also recording that. If the recording is fantastic, I can publish that for you to have access. Okay, then we have Poisson distribution. These are all what you're gonna find in in 4101 that you need to review. Okay, X follow poi with parameter lambda. Okay, the probability of X equal exponential raised to power d divided by X factorial. X start for 1, 0, 1, 2 to infinity. Okay, we got negative binomial. Okay, the negative binomial, the probability of X equal to that, X minus 1 combination that, P raised to power R, okay, and 1 minus P raised to power X minus R, okay, S start from R, R plus 1, and so on like that. Okay, then after that, I think I've talked about like discrete, these are all kind of discrete distribution. Have you copied this side? Oh, go ahead. Oh, yeah, this is combinatorial, like combination. That's a good question. Yeah. Like I N choose X. Yeah. Okay. So okay. You see copying this, right? Oh, let me wait. Then I'm gonna write. Oh, let me even see. Oh, whether this can. Okay. Okay, so let me come. So these are discrete probability distribution. Now, talk about continuous. For instance, we're going to be talking about exponential. So if X follow exponential with parameter beta, okay, f of x, exponential raised to power this, 1 over beta, s greater than 0, okay, and we can have another form of that, you know, where we're just going to have this, okay, so take note for exponential, okay, we're also going to have gamma, okay, x follow gamma with parameter alpha, beta, okay, f of x equal x raised to power alpha minus 1 this divided by gamma alpha, beta raised to power alpha, alpha greater than 0, okay? Then you're also going to have a chi-squared distribution. I think this is going to, you should be done with this, right? Okay, now, okay, so you got, now for chi-square distribution, you know, if alpha equal v over 2 or beta equal to 2 in gamma distribution, okay, if you plug in all of that, okay, you're actually going to have v over 2 minus 1 x raised to power, let me see, x over 2, okay, then gamma v over 2, 2 raised to power v over 2. Okay, this is good. This is what we call a chi-square with v degree of freedom. Okay, now you're going to have t distribution. Okay, where we're going to say for t, g of t equal gamma r plus 1 over 2 square root of pi r gamma r over 2, or 1 plus t squared over r raised to power r plus 1 over 2. Okay, here t is actually on that. Okay, then you're also going to have f distribution. Okay, okay, you've copied this side, right? Oh, you say copying that? Oh, okay, so that means you're copying that. Okay, you know, all this distribute because if in statistical theory, okay, if you identify a random variable, we need to be able to know the probability distribution of a particular random variable. It's just like if I'm in Minnesota, I need to obey Minnesota law. Minnesota is going to have a map, right? Every probability distribution has a graph, like you'll be able to identify the distribution. Okay, so because of my time, then we're going to talk about F distribution. Okay, F distribution. You know, all these distribution, they were derived, but you did that in 4101. Like I said, if you go to YouTube and you put my name, okay, on the YouTube, you're basically going to see my lecture video for 4101 on some other one. Okay, so for F, so G of F equal F R1 over 2 minus 1 R1 R2 R1 over 2 V into R1 over 2 R2 over 2 1 plus R1 R2 F raised to power R1 plus R2 over 2. Okay, so the R1 and R2 is the degree of freedom. Okay, and your F is greater than 0. You know, all these distribution, they are very, very important when it comes to testing. Okay, if I want to conduct an F test, I need an F distribution because I actually need a p-value. Okay, you know, the p-value, if there's no distribution, there's no way you can get your p-value. Okay, if I want to conduct a t-test, I need a t-distribution. If I want to conduct a chi-square test, I need a chi-square distribution. Let me tell you this. It's just like somebody committed an offense in the state of Minnesota, okay, and the person now ran to California. If the person is tried under California law, even if the state of California was able to establish the fact that the guy commit an offense, whatever decision they take will be declared null and void. Okay, because he didn't broke California law, he broke Minnesota law. Okay, when you use an F distribution for T test, then you'll be wrong. Okay, review all of that. Any question for today? Any question? Any question? Okay, now this is what I used to do for me to improve. Okay, at the end of this lecture, I need you to send me a message, rate your understanding of today's lecture from 0 to 100. If your rating is less than 100%, tell me what you need clarification for. Does that make sense? Okay, because I like getting feedback. Okay, in the absence of question, make sure you all stay safe and have a lovely day. Bye for now, everyone.